Welcome to another episode of the .NET Show. Now, in the past episodes, we've been spending an awful lot of time focusing on individual technologies that are inside of .NET. Well, that's not really solving your problem all the way. What you really want to see probably is how a business actually uses .NET to solve their real problems on the real web. Well, today we've got a treat for you. Today we're going to talk to the people behind Microsoft.com and understand how they're using .NET to solve their problems. We'll be touching upon some of the technologies, but specifically we'll be talking about how they envision the entire .NET framework and how they're using it to solve their problems. But first, let's check in with Erica and the news.
Hello, I'm Erica Wickers. Welcome to the MSDN News Update. Microsoft recently announced that it is preparing a set of tools that will enable Java developers to take advantage of the .NET platform. These tools will be released later this year as a resource called JUMP, which stands for Java User Migration Path. The goal of these tools is to provide a path for Visual J++ and other Java developers to preserve their existing Java language projects and migrate those projects to the .NET platform. Using these tools, developers will have several different options for how to migrate their existing source code so that it can fully support the rich and language-agnostic .NET platform. In February, Microsoft announced that the next release of Windows, previously known by its codename Whistler, will be officially named Windows XP. XP stands for Experience and was chosen to indicate the work done to greatly improve the user experience. Windows XP is built on the enhanced Windows 2000 engine and features a significantly updated user interface. Windows XP is expected to be available by the end of the year, with the second beta version available in March. Also in February, Microsoft released the Office XP Smart Tag SDK. Smart Tags is a new feature introduced with Office XP that intelligently links content in Office-based documents with related content hosted on servers, websites, and in files. The Smart Tag SDK contains a full set of documentation and code samples to help you create Smart Tag actions and recognizers. In early March, Microsoft made available a beta version of the XML for Analysis SDK and an updated XML for Analysis specification. XML for Analysis is a new protocol that enables the transfer of information between analytical databases and client applications, regardless of the computer language used to write the application. Be sure to check out the show transcript for links to more information on these news items. And that's been the MSDN News Update. I'm Erica Wickers.
The importance of technology, obviously, is to allow all of us to do our jobs better and have a business out on the web or wherever. So talking about .NET as a technology is only covering part of the problem you guys are interested in. What you really want to find out is how a real business that's really on the web is using .NET and its technology to solve their problems. So to help focus on some of those, I've got with me here Tim Sinclair, General Manager, and Mike Moore, a Development Manager for Microsoft. Both of these guys work on Microsoft.com. And so we're going to take and focus on what Microsoft.com is doing with .NET and why they chose to implement some of these technologies. Now, Tim, before we get into the .NET capabilities, maybe you can kind of help couch the idea of what exactly is Microsoft.com when you guys think about it.
First and foremost, Microsoft.com is our portal to the internet. And it's for customer support, for downloads, for product information, are really the main three things that people come to the website for. It's a pretty large website. We see about 5 million users daily. There's about 30 million on a monthly basis. It's sort of roll over from month to month. We're in 40 languages, and that kind of adds up to about the 4th largest on the internet. So we really think about scale. The second thing we think about, besides just being a portal on the internet, is really using our technology and stressing it at the absolute max. And so we adopt a lot of Microsoft technology in its earliest stages and then work with the product teams to really give that feedback.
Now, the pages in particular, I mean, how many pages are on Microsoft.com?
There's about 400,000 to 500,000 pages, and I say 400,000 to 500,000 pages because that changes pretty frequently. You can publish basically every couple of minutes on the website, and again, that happens on a worldwide basis. And if we have a big launch, something like the next version of IE, it gets really busy. Everyone's trying to refresh and put a lot of new pages, and it takes a little while to delete some of the others. But yeah, about 500,000 pages.
And so when you decide to adopt some new technology on your site, is that covering all those 400,000 pages or just like the homepage?
No, it's all 400,000 pages. So you have domains and you have subdomains. We have data centers in several different continents. We have data centers all across the U.S. as well, in several different places for downloads. So when we say adopt the technology, we'll adopt it in a space to make sure that it really works, and then it becomes a migration rollout plan from there.
So when you adopt it, it's a big adoption.
It's a big deal, and so we really have to think about the amount of manpower that we can throw at this problem, because obviously we don't have infinite resources. I mean,
how big is your team?
My team is 100 people, but that includes software development, program management, product planning, localization, and operations. And so there's just not enough people to go around when you're trying to maintain a website of this size. So we do have to think about efficiency. So in the world of P&Ls, or profit and losses, I'm an L. I don't have any real profit. I don't really sell much online. So getting free headcount and operational efficiencies are just really important to us.
So what started you thinking about adding .NET to Microsoft.com?
Well, one of the challenges we have is with a relatively small development team, I'll call it 25 people, that you don't have time to focus on each specific problem from beginning to end over and over and over again. I mean, you could take, for instance, registration, downloads, search, product catalogs, home pages. Once you get done with one, you need to redeploy resources to the next generation of each of those. And so we found that, beginning to end, that takes a lot of high IQ. And so we were coming up with interesting applications for the web, but they were monolithic. I mean, what we'd done is we'd taken all the good learning of software development discipline of, separating code and data and presentation, and we throw it into one file, ASP or HTML. And so we lost some of that great efficiency that we really saw in the computer science world. And so with .NET, we saw some pretty neat ideas come back in that we begin to separate things and build a series of loosely coupled components that could maybe be used for the specific problem we were trying to solve, but maybe be repurposed to a totally different problem that we hadn't even thought of yet. And so rather than thinking of reusable code, we really thought about reusable services. So there wasn't the recompilation and all the other kinds of challenges that we might have, and deployment as well.
So just between the three of us, I mean, your choice of using .NET, was that purely because you work at Microsoft, or was there something else there?
Well, surely there's some influences there to use .NET because it's one of our key flagship product offerings that we have, and I want to be the first and brightest on top of that to lead the way from Microsoft. But there's clearly business benefits because this website, although we have 5-6 million users a day, certainly I'd like to really extend that reach quite a bit further. I know that I want to be able to extend my staff any at all. So I need to do about twice as much this next year with the exact same staff. So I've got to find a smarter way to use technology as an enabler to just change the dynamics of the game.
And you think .NET is one of these technologies?
Oh, clearly I do. I mean, we've been XML proponents for a long, long time. One of the earliest consumers of XML, although .NET is much more than XML, it's certainly one of the underpinnings of it. That gives us the ability to almost syndicate information in different ways so that customers can see the right information in the way that they'd like to view it. And we're really not thinking just about the web. When we start thinking about .NET, we're thinking about the ability to grab content and repurpose it to many different mediums. I mean, you think about MS Press as being one of our best sources for quality information in books. Wouldn't it be great to have more of that information online so that you could actually, whenever you have a problem in one of our applications, we could not only point you to the support site, but we could point you to some tips and tricks as well as the page of an MS Press book that you could get online to begin resolving your problem. You don't have to run to the bookstore. So we're thinking much broader. How do we do many more things this next couple of years with the same staff.
So, Mike, when Tim first came to you with the topic of let's jump into .NET, what were some of your first thoughts?
Well, we were actually pretty excited about it because we've always believed in componentization, but one of the biggest challenges in building components on a large farm when you have international data centers is the deployment of all those components. So you need to register, unregister existing versions. When you have large farms and hundreds of servers running around worldwide, the mechanics and the logistics of pulling that off are kind of tricky. What .NET Framework offered to us was the beauty of componentization with the ease of deployment that the scripting languages had brought us. So we kind of got the best of both worlds, and the performance that you get in a compiled language. So there's really no trade-offs. You get the rapid development that you would expect with a scripting language, the ease of deployment, which makes your operational teams happy and they're delighted with it, and very, very good developer productivity, because you get very powerful languages without having to do a lot of the memory management and a lot of the other mundane, sometimes relatively error-prone parts of the development process. You can really focus on just the feature set of the application. Of course, Tim would like to see us develop maximum number of applications and functionality in minimum time. So that allows us to get more product out the door and get it shipping. The other beauty of that is that when we design these components or services that then get called, they can be tested once, run under stress, you can rate their performance, and then you can start reconsuming them with multiple UIs and bolt those on as you see fit. So we really look at the services model as being the key to our future, plus syndicating. Get together with third parties and make services calls across the third parties. For example, we consume Passport as our login service. And that's provided us a lot of functionality without having to do that work.
But doesn't this mean a whole new way of thinking? You're almost going to toss out all of your old stuff in order to consume this new .NET stuff?
It's the return of structured programming is the way we're kind of looking at it, is that we kind of lost our way there for a couple years. The internet was great, and you had these kind of static applications. At first, you just had HTML, and then you would just link around casually, and life was good. But as we started to build more functionality and started to build applications out of it, we found that the application development environments were somewhat limited. They were more of a go-to programming style where you have one large monolithic chunk of code with hundreds of includes, and to build really large-scale enterprise systems out of that is pretty tricky if you have a very large development team. So the ability to get back to sort of an N-tier type of an architecture, and with services it's taken even further in that you don't have to worry about the deployment and the calling of remoting across machines. That's a huge benefit. Before, in our environment, we'd have to set up DCOM ports and a lot of other functionality to do the cross-machine calling. And now with HTTP, we can make those remote calls very, very rapidly without any additional operational overhead.
It's almost the only way you can get to worldwide, too. I mean, because when you start thinking about getting to 40 languages, and if you have all that in 1 or 2 or 3 files, you send that out to localization vendors, and they're going to understand language and translations. They're certainly not going to understand different code paths, and so invariably your code gets stomped on. Now you have to retest in 40 different languages. With this back to the structured programming again, we can actually separate that out so cleanly. So we can send files off to localization vendors, ship a service, and then bring in new sets of files as we need them, or simultaneously ship without actually affecting or re-registering any services.
So you're separating the content from the code, and the content is in like XML and HTML?
The content is totally XML, and so in the specific areas where we really do a great job of 40 languages, and clearly we'll do the whole site in 40 languages in the future.
The beauty of building a web service on top of it, as opposed to saying just exposing a whole series of files, is those URLs may change over time. So by going through the rigor of actually defining an API layer that you're going to support for a period of time and allowing people to start calling into it, you're basically making a contract with them of the properties and methods that you're going to support from now and many, many years in the future. If you just give them URLs to flat XML files and stuff, it's very difficult if you come up with new innovations to maintain that structure. You all know the broken link problem. Well, with an XML world where you're building applications that now depend on the physical locations of specific XML files, that's proved to be very difficult to support. Having this middleware that abstracts away the physical implementation is a huge benefit. Then you can rebuild it on a SQL Server backend, or on a file store, or on index server, or on some other store that's appropriate for the type of data that you have, but maintaining a uniform API. And then you can then integrate these services and then place a UI on top of all of them.
It helps us with a long-term approach as well, because if you say, well, just get a bunch of URLs out there, people think those are temporal and that they can change them easily, and they can. But if you say, I'm building an API, I'm going to build a platform that people can adopt and can reuse in new and interesting ways, they actually think through the problem a lot more. It doesn't take them any longer. They actually plan for the APIs and how it would be consumed going forward.
So it's a different mindset, kind of.
Totally different mindset. It's long-term.
Yeah.
Everyone thinks about, okay, this is going to last for 2 or 3 years before we do any huge retrofits. Whereas in a URL, it might be gone by, this afternoon, because we may just change that around, and that's the flexibility in front of the web. You'll still get to do that, but the underpinning services where we applied some high IQ to, we're going to kind of lock those down and say we need to plan for that.
We use the web to some extent as an excuse for formal software discipline. We're actually going through the trouble now of defining the APIs, how are the calls going to be made, what our long-term future of those API structures are going to be. All that stuff that in the web you just kind of cranked out a quick page, put a couple of URLs up, and you're up and running and went on to the next project. We've all done lots of those. But if you want to start tying applications together, you don't want to break those over time. So it requires a rigorous contract between the caller of the service and the service itself. So it's forcing us to go through the formal software discipline that we used to do in the client-server world 4 or 5 years ago.
So with all this exciting work, and I can tell you're really excited about it, how soon before we actually see some of this stuff on Microsoft.com?
We've seen a couple of things already, actually not customer visible as much, although we'll give you some URLs today that'll show you how much more visible we can make them. Our customer database is all XML in and XML out driven with a SOAP interface, which is really helpful in building different kinds of registration on our domain of our website for profile and personalization. The next thing that we really spent some time on was search. And search is a gnarly problem. I mean, it's the hardest thing on any website. People don't go to a search engine and say, I love this search engine. So for us to make some dramatic improvements in this, we have to decouple the problem or decompose it into something smaller. And so our first step is we built a search website that Michael spent a little bit of time showing us, which is essentially getting best bets. Whenever you type in the word Windows on Microsoft.com, you'll probably get 400,000 pages back in a lot of different languages if you want. So it's a pretty broad term, and it's conveniently used by most of the people that create content. So what we've done is editorialize a handful of what we call best bets that say if you type in the word Windows, this is more than likely what you're looking for. The Windows home page, maybe hardware compatibility list, etc. And through usability focus groups and just watching people's patterns on the web, you can sort of figure that out. Well, best bets can be reused in a lot of different places on the website. We've just begun to think about that so that search doesn't become this monolithic application, but you can actually make finding information, discovering information become less of a task on the website, more of something that just happens. So the first thing that we have is really search and best bets and then breaking that apart. And then the next generation is some applications on top of it.
And then Jay's going to show you a little later in the show doing secure services, which is an extremely advanced system, a very complex system with lots of functionality to secure all of the things we do online in a uniform way, all built on .NET frameworks. And that raised a few eyebrows when we said we're going to put our entire secure services system on, alpha code, basically, and then now it's become beta 1. But we felt so confident in developing it. First of all, it was the only way we could develop it that quickly enough to be able to get it out in a reasonable time frame. And secondarily, we found the system to be very stable. So we actually found that in the beta, it's very, very sound, and we can put an enterprise style of application on top of it.
It's also a project that, from a manager's perspective, what used to take a couple of years to build a set of secure services, now in 90 days we have serious traction. We have real code working, and it is elegant, a totally decomposed framework where you can actually reuse these parts in many different ways. So that, just from a managerial perspective, is very, very exciting.
Yep.
I know the development environment's great as well, but I mean, stuff's getting done faster, and that's what I like about it.
And the framework is extensible. That's one of the other things is, as a computer science person, you always like beautiful engineering. And in the case of the frameworks, when you add new functionality, there are seamless extensions to the framework, rather than feeling like they're hacked on top of it. You can create your own namespaces, you can extend existing functionality that already exists there. It's a very uniform model throughout all the development process of both your own services, built-in services, and third-party services. It's a very, very elegant way to develop. And it brings, object orientation and inheritance and all those things we've always wanted, say, in Visual Basic, and makes it available through all of the languages running on a common runtime. And that can be put on multiple platforms. So it's really a feat of engineering.
So you're saying that you've already implemented some of this search capability on the website. Can we take a look at what that looks
sure,
like
you bet.
exactly?
What we're going to show you here is, if you take a look, you'll see the Microsoft.com homepage just as a starting point, and we're going to show a rather common customer scenario that if you've used the site very long, say you're looking for something like VB, so you go to Microsoft.com/VB, or say it was one of your favorites. Well, look at that. You get a 404 page, which basically says, hey, that reference no longer exists on the site. Maybe the vRoot was renamed to Visual Basic, VBasic, or something different. That's not a very pleasant experience for a customer today. You know, there's millions of people out there that know that when you say VB, your intent is Visual Basic, and they would expect the system to be savvy enough to recognize that, yet today we don't have that functionality. Now what we're going to do is show you the search functionality and what it provides, and then say, in a monolithic sense, and say, wouldn't it be nice if we could reuse that functionality to benefit this customer who's not been able to find the content that we're looking for. So if they clicked on the Microsoft search page today, they would go to the search destination. Notice this is not a service, it's an actual destination. It's an application with a UI tied to its back end. So we'll type in VB here and hit enter. And any customers out there, this is all live, you can follow along. And you'll see that you would have gotten some best bets to return that gave you some ideas on how to find the Visual Basic site. And if you were to click on here, you would have been into Visual Basic, where you say, you know, wouldn't it be nice if that functionality was provided as a service so that it could be consumed by the 404 processing part to actually take them to the right spot. And so we looked at doing that. I'll show you the various pieces of it here. First of all, we created this web service, and it actually is existing there today on .net.microsoft.com, and it has several methods here. One of the ones that we're going to show today, which is a very interesting one, is the Get Best Bets. So this UI that you see here, which is very straightforward, is created automatically by the .NET framework. So all we had to do was to create this ASMX page, and it automatically will create this UI for us, which is really nice. And we'll click on here to get down to this Best Bets method, and we'll type in VB, and we'll see that it's going to actually invoke that and return some XML, which is the actual best bets themselves. So if we look at these guys, we'll see there's Microsoft Visual Basic, and here's some various URLs that are the areas of the site that that customer may find interesting. So in this case, we invoked a service which then returned XML, and then now we're going to want to consume that through a user interface.
Just to simplify this a bit, so you wrote the processing logic code to query databases and do lookups through XML strings, and then you expose that on your website, but basically just sticking, web method on the top of the function.
That's correct.
And then what we saw in that ASPX file was simply the results of what all these web methods were, their properties and methods and their events.
And just so people understand, behind the scenes, that was originally functionality was written in JavaScript, and then we recoded it in C#, made it a C# assembly, put the service page on front of it, and we were in business. So it was a pretty straightforward conversion. So then what we'll do is we'll say, okay, we now have this service, so how could we make that so it's a seamless part of the experience? Well, let's assume one last thing I'll show you, which is the SDL contract, because I think this is something that people kind of find interesting. When you do this web method, what do you get out of that? You basically get the service contract, which gives you 3 different interfaces. Now, this is actually very, very nice, and I'll show you a little trick here in a second. You get a SOAP interface, a nice posting interface, and a standard HTTP GET interface. The beauty of that is that you don't need special tools to start consuming this right away. So you put web methods, you get your service up and running. You can go down and grab the HTTP GET method, say grab this Best Bets functionality, let's right down here, and let's see if I can highlight it here. I can grab that URL, copy it to my clipboard, pop it into my browser, have a little query parameter on it, and bang, that returns the exact same XML returned here that we saw before. So in the previous example, a SOAP call was taking place. In this example, there's a simple GET call using a URL through your browser. So somebody can very easily get up and running on this just by using the nice GET interface that's provided for you as well. So if you don't have a little SOAP tool that'll make these SOAP remoting calls and stuff, you can do the GET interface and you're ready to go. And then the same, when you actually have, say, an IE browser which supports SOAP, it'll make the calls over SOAP, that'll just happen for you automatically. So you don't even care the fact that it's being remoted over SOAP as opposed to remoted with a standard GET call. So as the final example, what we'll do is we'll go up and we'll say, here's what the next generation Smart 404 would look like. And this is an internal site, but it'll be shipping soon. And we see this little hourglass down here as it's looking up the best bets. And it just rounded those up, notice, in place. And I'll refresh that one more time so you can see it kind of happen again down here. Bang, it found the best bets. Notice how we didn't change to another page or anything. It made the call. It was a SOAP call from IE to the service, returned the XML, hit it with an XSL style sheet locally, and then displayed the best bets in place right on your client.
So, I mean, the cool thing about this is we wouldn't have developed a search service to fix a user experience on 404 errors on the website. I would normally look at my systems engineering team and say, we're getting a lot of 404s. That must mean people are asking for different things. We need to have better best bets in our search. Why aren't the users typing this into search? But we're able to take what I consider a loosely coupled service, the ability to use best bets, highly editorialized. We've already put our IQ into that, and then just do a little bit of word record at the top, pull off anything past the slash there, pass that into the best bets, bring back the answer, and of course, we'll make this user experience much better over the site. This is obviously just a quick prototype to show you the power of it. But you can imagine this happening anywhere in the site, anytime you're looking for anything. So, I mean, do you want to shop for something? Are you trying to purchase? Are you trying to get support? We could, it's almost like a question and an answer database that we can push into our website and give customers answers back.
Now, I've seen sites do things along the same order where I get a 404 error, and what they normally do is they take and they say, well, gee, here's an address that failed, and they hand tune it by going to a database and adding, here's the URLs it should have been going to instead, and so it just automatically does that redirection. How does this different from a functional standpoint? What do you think the service it provides you is better?
What it does is it has an abstracted interface on top of it so that we can change the behind-the-scenes implementation. So today we might be using site server search with an XML cache sitting in the middle of that. You can re-implement it on some form of different technology that may be improving. Say you got a more distributed technology. The beauty of it is by putting the service interface on top of it, whether the underlying storage mechanism is XML, it's a SQL Server database that returns XML, it's say a site server search which returns XML, none of those really matter to the consumer of it. The API that they use to call into it is just use MSCOM search service, call a method on it, pass some values, and they're done. Regardless of the technology that we use in the future, underneath those calling interfaces will never change. So it provides that elegant abstraction level for them.
If this wasn't a service, I mean, you can think about all the data centers that I have in San Jose and Chicago and West Virginia and Tokyo and London. I mean, if it was a database totally driven, then what we'd have to do is make sure all those servers are configured. Anytime we change any of the back-end data stores, we have to, if there's some COM objects, we have to make sure that those were installed on those servers. And we don't speak the language of a lot of these people to actually help them configure this at the different time zones. This way, all we have to do is just say, prop the content. We can prop it here from the US, or we can prop it from Japan, wherever it needs to be. And the page is there, and it just calls the service. And it's they're totally insulated from the complexities.
Yeah, it's also beautiful from a development standpoint as well, is that you could just change the config.web file that you have in the .NET frameworks on whether you're in your test environment, your development environment, or in your production environment, and it'll go be getting a different version of the service. And so regardless of the location that it's at, you can easily map to a new location if you were to move it. Or a lot of the time, a lot of effort is spent moving between your test, your development environments and then your production environments. And in the case of international, reconfiguring for international, maybe you don't want to go as far all the way back to a service that lives here in the US. Maybe you have an instance of that service living on some machines there. You can just reconfigure the config.web there to go to the service that lives there locally for greater speed. So again, this abstraction level of separating the actual transportation from the actual service features and providing a rigorous API is a very good approach.
So what are some of the other capabilities you think you're going to be putting on the site? I mean, the search seems very obvious. People actually touch it and feel it, and I guess they can actually code against it right now too. What are some other capabilities coming up?
Downloads make sense. I mean, because that's the second, I mean, people go to search to find content, types of content, generally support content, product information content, or downloads. And downloads are huge. So if you have a download service, that could be used not just on the Microsoft.com domain, but the subdomains as well. Support.microsoft.com, events.microsoft.com, MSDN.microsoft.com could call into a centralized, highly editorialized download service. That would be, really, really valuable. The other thing we're going to be moving to is content as a service. So if we start to think structured about our programming, now we can start to think structured about our content. So one of the things that we have underway is a taxonomy project to say, what are all the kinds of content that we have? how is it stored, and it doesn't have to be in one monolithic database, but just be able to refer to any different kind of content on the website in any different language, and essentially have a UDDI service that lets us use content as a service and then build our web pages off of the top of that. Obviously, that's something that we're really working forward to more in the fall time frame, because the hard part of this work is not the technology. The hard part is really the process of defining every piece of content, what customers want, how will they interact with it, because we're thinking about multiple mediums, not just the web. But once we get to content as a service, customer information as a service, and then search as a service, we really have some very, very powerful tools that we can start to mix personalization on any kind of content in any kind of scenario. And we think that's going to be very, very powerful without regard to the UI, because we're not thinking about the UI until after we get the services done, and then the UI comes on top of it. And
all those animated GIFs and things like that.
Exactly, those are my favorite. But I mean, because then the designers and the planners who really think about user experiences can just go wild, because the infrastructure will be there. And in fact, even customers could go wild and begin to design their own user interfaces, because we know what services would be available and would be able to expose them so that they could do their own kinds of interesting things.
All the key information we have, like Tim was saying, downloads and product information or customer stuff, and then a secure service that unifies those across the board. And internally, and customers will be interested in this as well, we're using like BizTalk Server as a service to move different pieces of information around in a workflow. So you build everything as services, and even internally, your own business processes, you can start componentizing so that you can have some process automation, say with BizTalk Server. So this whole notion of basically componentizing what you do and tying it together into new experiences transcends just what you do on your websites. It kind of changes the way you do business internally as well. So we're actually building a lot of our stuff to be very componentized so that we can tie it together with BizTalk Server for internal processes. Say the process that actually builds the catalogs, where things get localized, goes out to load vendors, they make changes, the XML streams back in BizTalk Server, then kicks off another piece in the workflow process, and then ultimately you get a catalog produced, the new information goes out to the site that customers then can then consume. And then now that you have all these services, they can build potentially or pick and choose their own UI elements that they want to display the information on Microsoft.com that they're interested in.
Even take a call center scenario. I mean, because obviously Microsoft is in a core business of software. And then when we do call centers or escalation paths, sometimes we outsource that functionality. And that's outsourced in different countries and different places around the US, and they handle the common questions, etc. Well, one of the applications that they need to build is the ability to get support information, download information, and product information, because they are an extension of Microsoft. In fact, they answer the phone with, hello, I'm from Microsoft, I'm ready to help you. But they obviously have their own systems, and their own systems help them do a better job of call tracking and call logging, and how often do I follow up with this customer, etc. And those are processes that we aren't even thinking about. But calling the set of web services, they can actually build some very interesting applications that tightly integrate with their business process and overall give Microsoft customers a better experience, even though it's through a third party.
Yeah, it's really struck me so far today that you guys truly are excited about what you're doing with .NET and Microsoft.com. Now, I'm hoping that my audience out there is equally as excited about it, but are there any key pieces of information you think are important to communicate to an audience like this that might be thinking about implementing .NET on their sites?
Well, I would encourage them to get started right away. The beta 1 is on MSDN. It's fairly easy to download that. They can get that up and running on their machines and start playing with it so they become comfortable with it and start.
And beta 1 is what you're using on the search engine right now. So
that's correct.
On Microsoft.com is beta 1 implementing the search stuff.
That's a fact.
Even with beta 2, we know is going to change the namespace drastically.
Yep, and we're going to make a few changes there and stuff, but it's not that much effort. We wanted to really get into the methodology. In fact, it's the methodology that brings as much value as the development world itself. It's the thinking through and having to bring rigorous software discipline, having to do object-oriented programming again. I mean, it's really the combination of the framework plus the methodology that brings with it, and that you have to do a lot of thinking about what you're building and how things fit together and how you're going to maintain interfaces over time. And then you get the flexibility for the future. You don't know all the possible ways that you would glue these things together. So what people should do is get started with it, download it. They can start writing in the language of their choice. Visual Basic is a first-class citizen with the Common Language Runtime, which is wonderful. I personally love Visual Basic, and it never had inheritance and you know, some of the structured error handling that it has now. Visual Basic and C#, and you know, we even saw one of our partners build a COBOL version that runs on the .NET framework and the Common Language Runtime. That was astonishing, to say the least. Brought back some memories for me, I can say. It's exciting. I mean, when people get into that and start using that for development, the fact that they can just do using the service, inherit the functionality it has, and get to work on it, and do this transparent remoting across machines is just a level of power we haven't seen before. And it's just something that's just delightful to use.
From a business perspective, and I've worked with a few customers to help them think about the next generation of their websites. The really interesting part of it is the loosely coupled systems. I mean, if you start thinking about the whole business problem, just a call center would be a great example. That's a really hard problem, and the processes there are very intensive and very thorough. But if they can start to begin decomposing it and saying, okay, I have a service here, a generic service there, a generic service there, it turns out to be that they can solve 60–70% of their problem on these base services, and the rest is process and user experience. And that's the fun work for people once you have the base services done. Just but get the plumbing done, and they're finding some pretty neat business opportunities because they're not having to rethink their entire business every time they see a new partner come online.
And we're finding that even internally, we have our own web services that we start consuming as a development team. You know, say you have a nice string operator function that nobody's seen before. On your development machine, you have that running. It's one of the services, and you can consume that at any point in time. You need that functionality. You don't have to go chase somebody down to try to find a type library so that you can start calling to these services. They already exist. So it's really neat. We'll see a tool later that Jay will demonstrate where if you hear of a service living somewhere, you can turn this tool at it to get a nice type library generated locally, and then you're writing at it in Visual Studio using the autocomplete functionality and everything. It's very, very nice. It's a very pleasant environment to develop in, and you can get applications out in a hurry.
Well, thanks. I really enjoyed talking with you and the enthusiasm I'm feeling from you about .NET and the .NET framework and things. And I'm excited to find out, what's going to go on next with Microsoft.com, and looking forward to some cool and exciting capabilities there.
Thank you for having us.
So that deals with some of the business aspects of what Microsoft.com, the website, thought about when they were implementing .NET on their systems. Now, after this short break, we're going to come back and we're going to talk with one of the developers and seeing some actual code that they use to develop some of these services, and also showing you code that you can implement today on your websites that ping against those same web services. So stay tuned.
So here we are again at the end of a long, hard day of fruitlessly attempting to find Bill Gates to present him with the gold-plated propeller hat from MSDN in recognition of his status as the chief propeller head at Microsoft. And what does any self-respecting, intelligent, hard-working employee at Microsoft do after a long, hard day? Let's go bowling! I think that's my ball, sir. Excuse me. Sorry. Okay. Thank you. Well, here we are at the bowling alley, and we haven't found Bill all day. I know we're not going to find him at the bowling alley, but who cares? Let's have some fun and bowl a few frames. Yes! Yeah! Well, I think I'm doing pretty good today. If I'm not mistaken, I'll break 88 for the first time in a week and a half. Let me check my score here. Let's see, not bad, but hey, that guy in the next lane, he's doing pretty good. 79 in the 6th frame. Bill G. Bill G. Whoa! Hey, Bill Gates. What an incredible coincidence to find you here at the bowling alley. Look, Bill, I have been looking for you all day long. I'd like to present you on behalf of the Microsoft Developer Network with this gold-plated propeller hat. in honor of your stature as the chief
I'm not.
propeller
My
head
name's
at
Bill
Microsoft.
Gordon. I don't think
So
you don't
let me just go
understand.
ahead and put this on your head here. See how it fits
My name's
great.
Bill
It
Gordon.
looks wonderful.
I'm from
It looks
Wenatchee,
fantastic.
Washington. I'm
Listen,
here.
I
I'm here to
wanna
visit
thank
my
you.
sister for
Thank
the
you.
weekend.
Your sister from Wenatchee, I'm sure. Well, thank you very
Wait
much.
a minute.
It's been a tremendous pleasure to meet you, and I'll see
Listen,
you back
buddy, you
at
don't
the
understand.
campus.
I don't
Take
want
care
to wear
now.
this thing. I don't understand. What are you talking about? Here, take it back. I don't want it.
What an incredible stroke of good fortune. We've been looking for Bill Gates all over town, and here he was after all this time at the Sun Villa Bowling Lane. This is one of the most significant days of my career at Microsoft.
Hey, you got it all wrong. I'm Bill Gordon from Wenatchee. Hey, stop. Take your hat.
Poor Andy. All that work, and he never did find Bill, did he? Well, I guess that's the breaks. Well, here we are back at the .NET show talking about the programming aspects of .NET. Specifically, how the programmers at Microsoft.com use to add .NET services to their website and how they're planning on implementing it further on. To talk with me about that, I have Jay Nanduri and Mike Moore again. Now, Jay, you're a technical lead for Microsoft.com, and Mike, we already know that you're a technical manager there. Now, in the previous segment, we talked about the search engine. I realized there was some coding aspects you wanted to show, and so I asked you to kind of hold it off to the programmer segment here. So why don't we take a look at that programmer thing you wanted to show us there?
Yeah, what we're looking at here is this will give a chance for people to hit something live. If they actually go today to .net.microsoft.com/ and then hit it, they'll actually see we have a little portal site here for our search service, which can be clicked on. And you'll see there's some information about using it, there's a backstage article and so forth. What I'd like to direct your attention to is if you go down to the very bottom and you type in, say, VB or DirectX or something that you're interested in, it'll actually exercise that service that we saw earlier, and then we'll take a quick look at the code that's involved in doing this. So we'll say search for best bets, and you'll see that we get some results returned back. Notice that all occurred client-side. So there's kind of an important piece here, which is, in this case, what's happening is IE has a little-known feature, which is SOAP implementation client-side. So it can actually make SOAP calls against the .NET service, or any other service for that matter, package and unpackage the SOAP call, the XML comes back, and then we take the XML, hit it with an XSL style sheet client-side, and then render it here. So what we're going to do is, this is the ultimate in low barrier to entry, is you just do a right mouse click and do a view source, and that's bringing up this client-side code. And we'll bring it up full screen so you can take a look at it. And if you scroll through this code, you'll see there's a couple interesting pieces about it that make this magic happen. There's this init function, which basically is binding it to the service, and then setting up a callback function, which will come back into this call best bets here. And if you look through the code, you'll see that how this takes place. And basically what you're doing is you're making an asynchronous call, SOAP call. It goes to the server, gets processed, and then a callback occurs, returning the resulting data locally, and then it's displayed. This is all written in JavaScript client-side. And one of the cool things about it is that Internet Explorer automatically builds this whole SOAP interface in JavaScript for you, and then does all the calling for you. So basically, you don't have to create a normal client-to-server web service scenario to get started. You can create your web service, like in this case, we're using search, get your client up and going, copy this code in, paste it in locally into your browser, and you're calling the service over SOAP, and you're up and running. So it gives people a really quick way to get in the gate and get started. And they can just take a look at this code and see how we're doing it, see how the XML and XSL are rendered locally, and then it's displayed. So it's a quick way of people getting in there and getting started. And they can just do a view source, grab a copy of the code, and start playing with it. And they can see how to call the search service immediately without even needing an intermediate server. They're just up and running. And then there's one last little trick, just to be aware, is that when you do this, Internet Explorer will create a little file. There's what's called an HTC file, and this file is actually a JavaScript file which has all of the SOAP signatures in it and all of the core code to actually make the SOAP calls. So it uses client-side XML HTTP and makes these SOAP calls, and then does the packaging and unpackaging for you in this JavaScript. What's really cool about it is that you can actually see basically what the SOAP protocol would look like in code just by looking at that file. And it's just source file. You can open it up and take a look at it, and it'll just be sitting there looking at you when you make one of these calls via
Where would that file come
behavior. When you actually do the behavior, it'll create the file for you in the same directory. I don't have the link for it on this machine, but in the same directory where your behavior is created, When you create a client side, there'll actually be a file that'll be sitting there with an HTC extension. Let's actually look at what it would have been called in this case. We'll look it up here and we'll find out HTC. And you'll see it's webservice.htc, and that's the magic that makes the behavior actually work. And it has all the SOAP signatures in there and all the code that does the XML HTTP calls back and forth. And you can see it creating the headers, making XML HTTP calls, returning the headers, and unpackaging the final XML. And then in this case, you'll see if you look at the code in more detail and search, is that a style sheet is then applied to the results, and then the little UI is generated at the very bottom as the final step. So that's a quick way that somebody can just grab a service, start calling it, and then take a look at a code sample to start calling that service.
And they can even use that today with your search service.
Absolutely, at this moment. You can just go into this window, grab it, paste it in your browser, and start hitting it.
Cool.
So it's a pretty neat way of just hopping in there and getting started. And there's no intermediate stuff required. You don't have to do anything to get working with that today.
So now, Jay, what has your involvement been on Microsoft.com and getting the .NET stuff working?
Yeah, we are building a secure environment or a platform where ICPs like MSDN, TechNet, who have secure content like universal downloads and things like that, they can host it on our website, or they can host it on their own system and call via the web service API into the Microsoft.com's authorization profile store and get the information about the customer, validate if the user really has access into the site, and let him have access. So if you look at the typical Microsoft.com site, it consists of the different varieties of content. The content could be free content, where you don't need to pay for anything, and the other content is secure content, where you need to have some vested interest in this content. So either you're paid, or your association with your company or an organization or anything. So if you look at...
Would that be like an MSDN subscription? So I'm a subscriber to MSDN.
Exactly.
I get access to a little bit more areas of the site than I could otherwise.
For example, if you look at the MSDN Universal subscription, they can download VisualStudio.net bits, whereas if you are not an MSDN subscriber, you are coming as a free content, then you can download the frameworks on the MSDN site. So you can distinguish the free and the secure site as that. So if you look at the project that we are doing, the thing is, we do not have any UI to show to the people. Everything happens behind the scenes. So if everything happens fine and the user got to the content, that means we are successful. So if you look at that way, we are holding a key piece in the whole workflow where who is the user? Is the user says who he is? And if he is so, does he have access to the area that he is trying to access? So what we try to do is, first, if you look at the problem space, first we need to intercept the request that is coming in. So the user could be accessing a foo.asp or a foo.htm. First we need to intercept the request, and then what we need to do is we need to see if the user is already authenticated. Authentication is nothing but passport. If the user enters his passport and gives his thing, then we go to the passport site, validate his credentials. Okay, is his passport correct for this passport? We get back. Then passport gives a thing called PUID, which is a passport unique identifier. That is what a foreign key into our system, into our authorization profile store. So what we do is we use the PUID and look at the user's credentials in our database and look at, okay, does this person have access to this content? If he does not have access to the content, then we need to put him to a place where he can get the access to the content. For example, a user has come in and he's trying to access the universal subscription area. He does not have access to that. Then what we do is MSDN would have a page where he can give his credit card number and buy the access to the MSDN universal subscription. That's where we put him. So the complexity in our project is we work with the various ICPs and we work with the various ICP workflow processes. So we need to provide a layer which is flexible to program, and we need to give our API in such a way that they're easy to use and easy to version control. So if we need to publish new API, we don't need to ask all the other ICPs who do not need this kind of feature to upgrade. So the web services and the .NET has been the best thing happen for this kind of scenarios. If you look at the previous programming scenarios, we used to give some kind of a COM components which are used to be at bits that we need to distribute to all the ICPs. So whenever we had a new version, then we need to distribute all these DLLs to all the ICPs. They need to go through the regression testing, and also when you give bits to some other ICP when they're putting on their boxes, they need to be extra cautious because these are not the bits that they have built. So they need to do an integration testing and everything. Now the web services has provided a way in which we don't distribute any DLLs, we don't distribute any bits at all. We provide all the service at a central location as a web service using .NET remoting. And an ICP, when he wants to consume the service, he uses a tool called schema extractor, which is also called SOAP sets. He goes to the URL and says, okay, I want to use this particular web service. Give me all the metadata. And metadata is nothing but, if you're talking about a C++ scenario, it is like a .h file where it has all the signatures of the files, what kind of objects it has, and things like that. So it extracts all the information for you and puts it in a C# file. There are multiple varieties. You can get an XML out of it, you can get a C# file, or you can ask it to build a DLL for you. So what the ICPs do is, the bits that are putting on their box is what .NET generates by looking at the URL. So they generate the bits and they put it and they reference in their code. So I can show you quickly. The way I want to show the code is, I could show the secure services code, which will not be available for the people. So I would start with the sample code that comes with .NET Framework, such that people can start playing with it. I'll just show a hello service. What this web service does is, if you call hello method with a name, for example, you send J, then it says hello J. Okay, so
very useful service.
Very useful service. So what it is doing is using system. It is the namespace of the .NET, and the next thing what we've done is we created a namespace called hello service. What it has only one method. Okay, it is a class called hello, and it's marshaled by reference object. In .NET there are different kinds of objects, marshaled by reference objects and marshaled by value objects. Marshaled by value object is nothing but the whole object and its contents are marshaled back onto the client. And marshaled by ref object is only the reference is marshaled, and the call is done through a proxy, and the proxy is nothing but what they're extracting from the URL. So if you see, we created a public method called hello method, and it takes a string name. And what we're doing is, okay, return hi there name. As simple as that. And to put it to create it as a web service, they can just compile it into a DLL, and what they need to provide is a configuration file that goes with it. What a configuration file is, the .NET remoting, the beauty of the .NET remoting is, if you have your web service and the web service is hosted on a web server, it could be hosted on a web server, or it could be hosted as a Windows service, and it could be responding to the different kinds of requests. It could be responding to the HTTP request, TCP/IP request, SMTP. You can think of any kind of request. So it provides, the SOAP is the protocol by which all the packaging, the serialization is happening between the client and the server, and your code base is the same. So you do not need to worry whether the call is made via TCP or via HTTP. You have the same code base. So how exactly you would tell what code base, what channel that you're using? If you look at this, we call this name as hello service is the name for the configuration file, and well-known object. What is a well-known object? A well-known object is nothing but, whenever you are creating a web service, it is the creatable object that the client can use. So here the creatable object is hello service is the namespace, and hello is the class.
Now, is this all code that the developer would have to write this file, or is this automatically generated?
This file he needs to, what exactly happens is, he needs to write these two lines, because when he generates the class, when he generates the file, depending upon which ICP that you are giving, who is the user, you will be expressing different well-known objects or different objects that they want to consume. So these are the two lines that you need to write to expose the service. So what we do is, so this is the class, and it says, and this is the channel. What it says is it is using runtime.remoting, and the channel is HTTP channel. That means it can use the regular HTTP. If you put port 443 or the HTTPS channel, then it's going to be on HTTPS channel. So after doing this, then you build the DLL, you put it, I could show you how exactly, everybody. It's as simple as creating a vroot and assigning to the place where the DLL is. For example, here I'm saying the prototype URT server. And once you do that, there is the CSG file that goes with it. It knows whenever a request comes in, it knows, okay, the request is being served on the HTTP channel. So it loads all the related DLLs or the assemblies into the memory. And now let's look at the Kali code. If I want to use this method, what exactly do I need to do? Okay, system is the namespace, and now I am using remoting to call this, so I need to load the particular assembly. So I call using system.runtime.remoting, and now I am making use of my service, which is hello service. So I'm saying that namespace, okay, I want to use my hello service namespace.
So now, is this code that you're writing on the server, or is this code that you're writing
on the client?
On the client.
On
okay.
the client who is using my service.
Right.
Okay. So what exactly he's doing is, it is as simple as that. As a C++ code, you create an instance of a hello object, because hello is the class in hello service namespace. You create the class new hello and enter your name. Okay, this is and you get the name. You call hello method on it, and you're writing the response. So the result is going to give you the hello method. What exactly is happening behind the scenes? When the thing is getting compiled, then the request goes, a SOAP request goes to the server with all the method and the parameters that goes with it, and the response comes back as the SOAP. And the remoting, that is the remoting sitting on the client, is going to unpackage all the data and is going to give you back an object syntax. So if you look at it, all these days we have been, when we have to do a web service call, we are putting the XML together. We'll shove it across to the server. Server takes it, decrypts all, looks at all the contents, makes the appropriate call, and constructs again XML and sends it back. And the client needs to go back to the XML to look at what exactly the written parameters are. What remoting does is for you is it does all the tasks for you. So it gives you an object-based interface. So it's a purely object-oriented paradigm where what you use and what you use on the server, you treat them as an object, and the whole underlying plumbing is taken care of with the .NET remoting.
So the decryption and decompiling whatever of the object coming back, is that happening within this DLL, or is that code, or is that part of the .NET services?
It's part of the .NET services. The .NET system is going to, whenever the SOAP request comes back, it looks at the format of the SOAP request. Okay, it is getting an object back. Mm-hmm. So it is going to hand you back the object, not the XML or anything.
Does it know the context in which you called it from? It knows the type of language you are, mm-hmm. and it knows what the data is coming in from. So it knows both the XML side of things, plus it knows the object side of things, and just does the right thing.
Does the right thing, exactly. So what I would like to show something is, in our project, if you look at it, we have different patterns of programming complexities. For example, we need to do some kind of a caching because a user is visiting again and again. For example, in a session, you might be browsing through different secure sites. So I don't need to authenticate you again and again. And also, once if I authenticated you and I cached your authorization profile, I don't need to query for it again and again. So there's a specific need of caching. There's a specific need of making efficient calls to the service. So what we did is we created different multiple Windows services which does the caching for us. And what we did is, in a way, whenever we are creating a web service, also we kept in our mind that all our calls are totally stateless. For example, if I make a call into my web service, okay, get me the authorization profile of this particular user, I don't need to pass any state around, or I don't need to keep my state around in a client or the server. So what we do is we manage all the state in the database. So there is a state manager which is living as a SQL, a Windows service which will be running on the SQL database. And the way we do the SQL database is we have a SQL master and we have a 16-way parallel horizontally partitioned database which has all the users related data. So whenever a user comes in, all his related credentials are stored in his own partition as a cache, and we refer to that particular piece. So all these things we built as a Windows services, and Windows services is nothing but an anti-services, which we call it Windows services in the .NET framework, and it is so easy to develop. So I want to show some simple service code that comes as part of the .NET, and what are the code I'm showing currently is what the code is available in the .NET frameworks as a sample. Then I can show the secure services code a little bit, because this is the code that any user can straight up get from the .NET documentation and start playing with it. And we say that it's a simple service.
One thing to point out is that Windows services historically, for people that either had the fun of writing them and stuff, that took a lot of work. In a lot of cases, those would take 2 to 3 weeks to crank out a true NT service. By the time you got it up and running and all the interfaces defined and everything. In this case, the service that you guys wrote for Cache Refresh, it was up and running in the same day. So it was a huge difference in actually time to market in terms of getting that functionality up and running. It's a matter of just inheriting that functionality and then putting your specific features in it.
Specific feature. So what .NET provides you is concentrate on your business problem. You don't need to write all the different plumbing. For example, I worked with the different programming with different distribution. If you want to provide distribution system, there are different technologies, and the .NET is the best thing that could happen, because you will be concentrating only on the business problem that you're trying to solve, and the rest of the plumbing comes as part of it. For example, if you were to write the same application in the COM, you need to take care of the H results. There is no exception handling, and you need to do query interface, and if you need to expose the same DLL for any of the ASP or the VB, you need to provide iDispatch. You need to all these things, all this plumbing is taken care of, because .NET comes with the type system. So a object in VB, in C#, everything is the same. So we don't need to provide these kind of things. And if a namespace is built as a DLL in any one of the language, we can use it across anything. And also the developers, if you look at whenever we are starting with n number of developers, we don't need to say that, okay, I need a C++ developers to do this task. Because any language is fine, and and any language is equally cool. And if you look at it, .NET came with the C# language, and we are embracing the C# language to an extent. And to tell you frankly, we have like 16 modules in this application, which is a very complex system. We built it end to end in 90 days.
Wow. Now, so you're saying you use C# most of the time, and Mike, you were saying you use VB most of the time.
Yeah.
And both you guys work in the same projects and trading code back and forth, and you don't even need to think about it.
But I've been kidding around as a manager. I don't get to do much development anymore, but the .NET frameworks have made it straightforward enough and stuff that I'm back. I'm in the game again, because I've always
loved it. Do you mind having me back?
Which is creating a lot of fear and uncertainty among the real developers on the team. But it's exciting to be able to know that VB now has the same functionality that C# has. The languages have equivalent functionality, live on the same core runtime. You can have a development team that has mixed skill set, which for a lot of businesses is very important. It may be that they're trying to recruit and they can't find the particular skill set. The ability to run a wide range of languages and develop in them is a huge benefit to people trying to attract and keep talent. It may be that you want to do C#, but you can't find a C# programmer. So you have some good VB programmers. They can use Visual Basic to develop their applications, and they'll be just as good of applications.
What about like C++? Do any people still using C++ for developing, or?
Most of the people in our development team who have been using typically C++, they're using C# because it is equally competent, purely object-oriented. Whatever you can do in the C++, you could do it in the C#. And the other thing is it's reliable. You don't need to. There's no memory leaks, garbage collection is there, and things like that.
Was there much of a training hit on that?
No, not at all. All of our developers picked it in They'll love it. They picked it in a couple of days. And we never went through any kind of formal training for this .NET because I know this is in beta stages. We went through the documentation and went off and built it. And it was not a major hassle. We didn't feel like we were adopting a new technology or anything. And it looked like a seamless transition for us.
Well, it's a lot of the functionality that we've always dreamed about having, and historically could get to work with various types of, amounts of effort and hacking is now built in and looking right at you. So you wanted to be able to make these cross-machine calls. So we do things like running server-side XML HTTP and, using some other technologies to try to spoof the system to get equivalent functionality. Now you've got the remoting built in there where the functionality is looking right at you. It's a very straightforward mechanism to make the calls. These nice object wrappers so that people get autocomplete and stuff so they can consume the objects very cleanly in Visual Studio is a huge benefit. Before what we had to do is the person had to load the XML up to a DOM and then figure out where the various things were, figure out how to use the node processing and stuff. They can now use the same object model type programming that they had done in the past, and all of that, constructing an XML, sending it across the wire, deconstructing it into an object out there, and it's all handled for them transparently. So it's a great benefit.
And I would show you what our tenants are liking the best about this is I would show some of the code that they need to do, what they need to do. For example, when we expose a web service, what is tenant doing? The tenant is doing something like this. I would show you. They need to run something like this, a SOAP search, and this is the URL on which we are exposing our web service. We call it as, say, SS tenant API, and the tenant API is the class that they're interested in. So they're querying for SDL, and in beta 1 it's called SDL, and in the beta 2 it's called WSDL anyway. So, and what they're giving me is, give me a DLL such that I can use this namespace, because whenever you want to use a type, you need to have what exactly this type is. Okay, if I'm using an object foo, I need to have the definition of the foo. So when they run this, what exactly it generates? It generates a C# file. So if you look at our namespace is called mscom.secureservices.tenant API, and it is giving all the methods. We have a ping method. I need to talk about the ping method. And we have get packages for title, and all the methods and what kind of things that they're returning.
What you did client side then, you said, I want to take and execute the services available at this URL over here. Mm-hmm. The SOAP suds went out, pinged the URL, looked at the URL, saw what all the properties, methods, events available there are, and then created locally a C# stub that you then compile that turns it into a DLL that then your application calls this little DLL and it automatically does all the SOAP stuff.
Exactly, exactly.
Historically, that would have involved, finding out who the author of the COM component was, trying to chase them down, get them to build you a recent type library, send it to you in mail. You'd have to find their components, register them on your server, unreg the existing, re-reg the new ones, put the type library on, and if it happened to match, you were in business. If it didn't match, then you had to go chase them down again. So this allows for very, very easy exposure of the interfaces that are available, and if they're updated, getting the new versions.
And other thing is DCOM. If, for example, if you are looking at hosting it centrally previously, you need to configure DCOM, and you know how difficult it is in this. And our systems engineers really hate it, configuring the DCOM and managing it, because there could be so many errors that going on if there are any burps in the network or anything. But this is so error-proof because you're going on an HTTP channel, and depending upon if I am, for example, within our group, say we have content management system and secure services, we both are talking to each other, and our web services are talking to each other. Then we could say, okay, we are lying on the same box. We don't need to go on the HTTP channel. We'll go on the TCP channel, which gives us 3 times more throughput. So we can go TCP/IP channel with no code change. I don't need to write new code to do this. I just go into my config file and say that, okay, now I want to talk TCP/IP.
And even more importantly is the config file is actually owned by our system engineers, so the developers aren't raising havoc with those either. Basically, we put out the services, and then the operations people can configure them the way that they want to configure them and manage them independent of the code. We don't have to go in and make a code recompilation if they want to change the channel that it's running under.
Okay. Yeah, and I will show another cool feature that we are using in the .NET is the reflection. What reflection does is it provides a way to go through encapsulation. It can break the encapsulation, and you can inspect the object properties and fields. For example, a request comes into the secure services, which is very crucial for us. A user who paid so much money to Microsoft to get into a website. Now, on one particular morning, he could not get into the site and he got an error. Now, when he calls a customer service representative at Microsoft, we should be able to pinpoint and say, okay, this is what the problem is. So we needed a way to log our requests and log all the users' session, what exactly they're doing. So we're doing using reflection. What we do is, at any stage of the user's process, what we do is the request at every process, when it moves from one module to the other module, we log it. We log it using reflection. So the whole object is there. So after the session is over, we can reconstruct and replay this session.
It sounds like an awful lot of data being stored, and it doesn't it time consuming and stuff like that?
No, it's very simple, because what we do is, in the object, we only store whatever the log request that we are storing. It's only the things that are salient enough for us to recreate the session. For example, to recreate the session, we need the URL and probably a passport PUID that he is using. So some kind of data, something like that. So this log handler, what it does is, this data, it puts, using encapsulation, it puts, okay, this object has these properties. And when we have this replay session going on, it can pick those objects on the request and replay the whole session, and we exactly pinpoint, okay, this is what the problem happened with the customer, and we can better support the customer.
Yeah, that's a functionality that's just amazing. Typically, most systems don't have that. In other words, if you have a problem and encounter the problem and a couple of days go by and then you make a phone call on it, the person really has no reasonable chance of ever getting back to the condition you were in when the problem originally occurred. With this way, with the logging, you can trace it back to the exact step in the process and what the current state of the system was at that moment in time. It's pretty amazing capability. It's made possible by reflection. Normally, the functionality would be hidden in the object. You wouldn't know what the state is, so there's nothing you could do about it.
Yeah. So I would show some of the code for the reflection that comes as part of the examples. Then later I would show how exactly we leverage in the secure services, because this code can be directly gotten from the documentation. For example, I have a factorial CS, which has got a factorial and which has got a value, okay, and a calculation function and everything. And now I'll show you a reflector which uses, okay, the purpose is to demo the reflection, object inspection and dynamic invocation. As it shows, reflection allows both. So you go, whenever you are instantiating the object in the reflector, you can go through and exactly, okay, if for this function call, what are the methods that I'm calling? In the dump class, you can get type name, class name, and you can write all the dump methods and everything. So in this way, what you can do is, this provides a very nice, elegant way of debugging your applications, and also when you are replaying the scenario, you can use dynamic invocation and invoke the object and call methods on it to call any related objects. And anytime, whenever we're creating web services, people have been asking us a couple of things. Okay, how would you check the availability? Because when it is on the web, everybody would ask, okay, is it 4 nines, 5 nines, 6 nines? And the second thing they would ask about is security. Okay, your web services now is available on the web on HTTP channel. How can you secure it now? Because anybody can call into it. So that we have used some kind of means. What we have done is, on each of the web services that we created a method called ping method. Naturally, it's like any TCP/IP ping or anything. A ping method which takes an integer level. So what we do is, if they they call a ping on the method, then we return back, okay, I'm safe and healthy and I'm kicking alive. And if they give a level of 1, then what we do is, it goes to the subsequent services it calls. For example, service A calls service B, C, D. Then it calls into subsequent calls ping methods and says, okay, I successfully called my child service B, C, D, and they're all alive and running. And when you give a level of 5 or anything, then we go all the way up to the database and see if all my connections are alive and everything. So our system engineers, they make scripts which run at regular intervals, which call the ping methods on this. And we can use these objects in scripting host or anything, and we can instantiate the objects, and they can call, they can write their method, and they can check the availability. So this is the method. So whenever we came up first, they said, okay, we need a means to check the availability, and we provided them. And the next thing is how you want to provide the security on the method. There are a couple of different ways. You could use the NT's typical challenge response and allow only certain users to come in, but you want to allow anonymous users, or you want to provide a role-based security on your methods and things like that. So what we have done is on our API, we created a method called logon method. So before they do anything with the API, they first log on with a specific role. And what we do is when they do the role, we stuff the context of what exactly the user is doing in the call context of remoting. And the call context is something, what exactly happens is when you're calling from a client to the server and server is called another component, call context flows across. So whatever the stuff that we have put in, we can extract at the any component level and do our checking. Okay, does this particular role, can it call this method? Because as a manager, you could be able to call, say, debit, but you, as a regular user, you should not be able to debit. So depending upon what method they're logging in through the API, we can check what they're doing. So we're using property bags or the call context in the .NET remoting to stuff our API security across. So these are the two things that, I wanted to bring it across and see.
This is huge, because if you think about it historically, the way that you would try to do this with a security context like this, you might have to add extra parameters to all of your interfaces, or if you wanted to change schemes later. The fact that the .NET frameworks has the notion of security in this context that transcends all calls and does all of the transportation of that call context for you is a huge benefit.
And again, it's almost like a hidden parameter that is being maintained across the calls.
Mm-hmm. Yeah.
I think that was a good analogy, a property bag, basically, that transcends the calls and moves around. When you have a distributed system going machine to machine, that maintains the security context across the machine boundary. It's a huge functionality.
Yeah. Now I would like to show some of the the reflection features how we used in the secure services. We created an object called debug object. What exactly the debug object does is it has got a protected method called get debug string of each field info. Okay, and if you see get all field info, it is going to the object value, it's calling get type, and get fields or the binding flags and everything. So the reflection is providing a means by which you can enumerate, you can go through all the fields of that particular object, and we can extract the information out. Then what we do is we selectively go through the object and build what are the strings that we're interested in, and that's what we put into our log request, such that we can replay the session later. So, and I would show some of the SQL connection, how exactly we are using SQL connection. SQL connection is part of system.data.SQL, which is a data access mechanism which is very optimized for SQL Server. So, and it has, we have already seen in our testing and things like that, it's 3 to 5 times faster than its predecessors. So it's pretty amazing. And the programming model is so straightforward. You create a SQL command object and you execute using a data reader. A data reader is nothing but it gets all the results back. So you get the reader back and you iterate through your reader, read, and do whatever you want. So what we have seen is the kind of programming model that is derived to us is so straightforward, and it is consistent across all the namespaces. The way the .NET catalog or the namespaces, they have been, they're coming up, they're doing an amazing job of keeping up the consistency. For example, cryptography. Previously, if we have to use crypto in Win32, it was a hassle, and Mike knows, if you want to encrypt and decrypt, you need to have a very specified individuals who know everything. Now it has been exposed in such a nice fashion that you have system.security.cryptography, and you have different algorithms that you could use, and they also provided some latest algorithms that we could use, which we are using to encrypt and decrypt our secure data that's going across the wire.
This is another big chunk of the productivity, is that consistency in naming is very important, because if you can't find the functionality, what ends up happening is you end up writing your own. So it's not enough that the framework all have a rich set of functionality. It's also important that it be organized well enough that people can actually find it where they expect it to be. Because if somebody doesn't find it, the first thing a developer does is, of course, write their own version, and off they go. But if you can find it easily, you go, oh, it needs to be easier to use and consume than to write your own. And if it is, you end up getting the reuse. If it's not, then you end up not reusing the functionality. So the consistency in the namespace, and that's something that also is being tuned in beta 2. That's one of the reasons some of the namespaces are changing, is to make sure that they're completely uniform throughout the entire system. And that's a worthwhile endeavor. That way, people who are consuming this over time will have a very uniform model to consume. And we're trying to also match up any namespaces we create to follow the same conventions and to make sure our documentation is identical to the way the .NET Framework documentation is written. So it all looks like just seamless extensions to the frameworks.
And typically in the past, if you look at, if I talk about the intercepting the request on the IIS, people have to write ISAPI filters and ISAPI extensions to do this job. Now ASP.NET gives the HTTP runtime with which you can write a pipeline model. For example, you can intercept your request and say, okay, before doing this task, I want to perform my custom authentication or my custom authorization, and it provides the way to do it. So what we're telling is, though we have an ISAPI filter solution, we're telling ICPs, okay, you have only a couple of pages which are secure on your whole website, like shop, for example, shop.microsoft.com. If you look at the whole catalog is public content, but the checkout page and say the credit card processing page, these kind of 3 or 4 pages are secure, so they don't need to install an ISAPI filter and take a hit on each request that is coming in.
Because the filter is just monitoring the pipe itself. Yeah.
So instead they can use HTTP runtime and they can write modules to access that and call into our secure services API. So we are providing our ICPs with the different ways, with a flexible mechanism to call into our web service, a flexible mechanism to consume our web service and intercept the request. It's amazing.
So what do you think then are some of the key issues in closing out here that developers and business people out there need to think about when they want to shift their big web application they have today over to .NET?
Okay, the first thing what they need to do is, okay, if they can centralize, if there is some kind of a functionality which is being used across their web application, for example, a checkout. If you look at an e-commerce application, checkout, address checking, all this kind of stuff which they have been using across
reusable features.
They can centralize them as services, as a web services at a certain end, so that anybody could call. And these interfaces will not be changing over the time, or you can maintain the consistency and the versioning such that if you upgrade one of your version to the next version, not all applications need to change, because typically what exactly happens is people have built COM DLLs or anything, so you have the code and the DLL, so people have been managing, and maintaining all the code around with them. So here what you can do is, on a web server location, you can control your versionings also, whether creating as a different vroot or creating as a versioning rules in the .NET, you can do any way you want, and you can provide a very clear interface, for all the other using applications, and you can isolate, the changes into your services, into the changes into your applications, because most of the time these applications change rapidly, but these kind of things won't change. Then you can isolate them and you can have different people work on them and where the interface is fixed.
Another thing that you can do that kind of makes it easy to adopt very quickly is set up a machine or two as a dedicated .NET Framework cluster. It could be a cluster of a single machine, and put some of your services there that are going to live there, and then you can do a pilot deployment where you can have your existing active server pages, say using the SOAP toolkit 1.0 if you're using beta 1. As soon as beta 2 comes out, then use the SOAP toolkit beta 2, and then you can actually make these web services calls server to server, having your .NET Framework cluster and your existing stuff running. And then as you become more comfortable and stuff, you can move the .NET Framework functionality because it can coexist on the same machines. But for people to get comfortable with it and get started, our recommendation, especially with beta builds, is perhaps to build it out on a dedicated machine, get it all tested out, put your services there and start calling it from existing code. Do some calls from client side, use an IE5 behaviors like we showed earlier, which doesn't even require an intermediate server if people just want to get started right away. And then as they get comfortable with it, then move your farm to .NET Frameworks. We're looking at doing that on the whole Microsoft.com farm in the very near future. Once we get up to beta 2, then we're actually going to install the .NET Frameworks across the farm, and then everything that's running on the site will be able to start using web services directly that live on the same machines.
So you're going to migrate Microsoft.com in its entirety to beta 2?
Correct.
So a beta version of the framework you're going to be running.
Correct. We're doing a little negotiating with our systems team at the current time to figure out the exact timing of making that move. Right now we've been running it on separate clusters and calling across. We'll get our search out and prove that out under reasonable load. and then we're going to go for it on the whole farm.
Yeah, we have some development and scalability tips that we want to share with the people. In the general system design, probably Mike could pitch in here. In the general system design, whenever you're building your core functionality, build the core functionality as a .NET service and isolate the UI from it. And maintain separate, clear separation between the code, data, and the UI. Such that because in the ASP.NET, what you can do is you can have code behind pages. So you can have an ASPX page, all the calling into web service and everything you can encapsulate into a code behind. And it's going to be a C# file or a VB file or anything, or it could be a DLL too, and you can isolate your UI from there. So when you're sending this UI to customization or the localization, you can send the just UI piece, which does not have all this calling thing and everything. And also design the system as stateless as possible for the maximum performance. And
yeah, typically what you find is, I know this is something that comes up a lot, but not everybody actually follows this, that it's a little extra work sometimes to think through the state management. Where is state going to be managed? Is it going to be client side? Is it going to be server side? Is it going to be on your database server? But it's worth doing that thinking through that, because if you look at the internet and the way that applications tend to work on the internet, users hit a page or hit a set of functionality and then sit for a fairly significant period of time, perhaps several minutes, before they move on. If you're holding, say, 100K of memory on that user's behalf, that might be 1,000 users that could have got in and been serviced in that same set of resources had you freed those up and remained stateless. On a farm like Microsoft.com, we want 100,000 users a day per box. That's the efficiency metric that we're looking at. In order to get that, we have to remain stateless. We simply can't afford to, support users in a non-stateless environment. We would require too many machines for the number of users we get. Thinking through your caching architecture, and .NET Framework has just awesome caching functionality. It even has output caching. So a complex request comes in, a bunch of processing takes place. You can store the resulting HTML for a later request and then send it back to the client. Another key part of the caching is to really, if you're an IE shop and use a lot of Internet Explorer, you can leverage the behavioral functionality that we showed that make your SOAP calls client side, and then all the work's being done. You're leveraging the edge of the network. You're not pounding your servers to produce all the UIs and then painting the picture and sending it back. You actually let the client be embarked on part of the processing. And then a final tip on like the IE client side is use the user data object for local client storage. A lot of it's a relatively unknown feature, but it's a feature that, especially in corporate network scenarios, is very, very useful, where an application needs some place to store information about what the client's up to, and they don't want to put it in a cookie because then it's a lot of overhead and passing it back and forth. So they can actually store it in the user data object locally, up to like 64K per user data object. So there's a lot of good functionality for storage.
And also one more thing is, all of our objects, whenever we're creating any object in our secure services API, all of our objects, we created them as a single call. That means a new instance of an object is created on every call, and this gets destroyed immediately after the call. So there are different statelessness. Yeah. So there are different. There's a singleton object and a single call object. A singleton object is going to live always until the request is there, and the single call object destroy. So all our objects that we're creating on our web service are single call objects. And also it would be very easy when you're in a cluster, when you're doing a load balance, your request is not always going to the same web server, it could be going to the different web server. So you don't need to have sticky sessions floating around.
Okay. Well, thank you very much. I appreciate you sharing some of the insides of what's going on inside of Microsoft.com and the code and some of the things you learned in developing those applications, and I'm sure our audience appreciated listening to it as well. Thank you.
Thank you.
Well, that covers some of the technical aspects that Microsoft.com is facing with developing a .NET service on their site. Look forward to a lot more capabilities being exposed on Microsoft.com in the future. And in the short term, take a look at some of their search capabilities on the site that they used at the very beginning, so you can kind of find out how .NET is being used there. And stay tuned. We'll be back in just a few seconds.
Welcome to another installment of Somebody at Microsoft.com. With me today is Arthur Yasinski. He is a group manager of the Content Samples and Subscriptions group with MSDN. Arthur, welcome.
Thanks, Erica.
Thanks for joining me. Tell me a little bit about what is this Content Samples and Subscription Group? What does that mean?
It's actually an internal group within MSDN, and we focus in 3 areas. We work on the architectural samples that kind of show customers how to use and showcase our technologies to understand developer concepts. There's a field content group that works with the field to produce events that customers may go to. And then there's the subscription team, the Pro and Universal subscription, that releases the subscriptions monthly and quarterly.
So what is your role with that group? What's an average day for you?
I'm the group manager for the team, so it's really just a matter of trying to pull all the pieces together, make sure that we're on strategy, on target, and we're trying to be as, I guess, synergistic as possible.
What are some challenges that you found with this new group?
Well, one of the challenges is keeping up with Microsoft technology. You know, I'm sure our customers can kind of associate with that, and internally it's the same. Trying to make sure that we're showing the right things, helping people understand what we're doing, and then making sure that we put it together in something that, you know, they can absorb and they can build on month by month, kind of quarter by quarter.
So how long have you been at Microsoft?
I've been with Microsoft since 1997. I used to be based in Canada. I just relocated to corporate here in July. In the field, I used to be a systems engineer, so I used to work a lot with the customers on site. And I had a developer focus back then too, so you know, this is my lifeblood.
Right. So how is it different working on the field versus working at corporate?
When you're in the field, you are dealing with customers on a day-to-day basis, and their problems basically are your problems. You're trying to solve them, you're trying to help them architect solutions. It's a little bit more challenging because there's an immediacy to it. You know, you're trying to solve the problem on that day or that week for that system. At corporate, you're thinking a little further out. You're trying to help architect a solution in the longer term, as well as put some programs in place to help people understand the technologies in the longer term.
What jobs have you had before you worked at Microsoft?
Well, before I worked at Microsoft, I used to work for Oracle Corporation. I was based in the field as well, and I was a systems engineer, or what they called a sales consultant. So I worked with a lot of companies building and architecting database-centric solutions. And so that gave me a really good kind of outlook, you know, for the Microsoft experience. As we get more and more towards the data-centric kind of world, you know, that experience has been great. And prior to that, I used to be a systems and network manager. So I dealt a lot with the IT kind of specific tasks where, you know, dealing with a heterogeneous environment, kind of rolling out multiple systems, you know, with obviously the service level agreements and everything like that. So that was kind of fun and challenging too.
So you basically had a full high-tech career ever since school.
Full high-tech career. I'm probably your stereotypical kind of computer person. I grew up in a remote part of northern Alberta in Canada, and right from kind of teenage years I was into computers. I think I got one of the very first TRS-80 computers that was on the market. I programmed and played with that, tried to understand how it worked. That led me to university and wanting to stay with computing, and ultimately led me to here where I'm still working with computers day in, day out. And I really don't know when my job starts and my hobby begins.
So what are other hobbies that you have outside of work besides computers?
Well, when the weather allows me to here, I do try to golf. And that, along with some of my other sports I'm familiar with, like curling and hockey, I like to try to do those. I don't do them as much as I'd like, so I tend to have to default always just to my golf game.
So tell me a little bit about curling. What is that?
It's kind of funny because right now at corporate we're talking about trying to get some events where teams are brought together and they learn new skills. And here in the U.S. there's not a lot of people who understand the game of curling, which really is nothing more than shuffleboard on ice. It's obviously more challenging that and difficult, but it's one of those sports that most people can pick up, and your whole object of the game is to like roll a 40-pound stone down a sheet of ice and to get it as close to a center pin as possible. And your opponent is trying to knock it out. So it's easy to describe, it's kind of easy to do, but it's still fun nonetheless.
So you get to do the curling here, but other than that, do you miss Canada? Do you get homesick often?
Yes, quite a bit, but one of the nice things is that we're in the kind of worldwide era now. It's an email away, is not that far away, and being in the western part of the U.S., it's easy for me to fly back home. It's like an hour flight in some cases, based on the congestion in the airways. Here I get home quicker than I would probably get to other points within the U.S. So it's not that bad.
So in Canada, do they like Letterman or Leno better?
Well, that's the New York versus LA answer or question. I don't know if there's a right answer. Most Canadians watch Mike Bullard. He's a comic in Eastern Canada based out of Toronto. So I'll stay with my homeland and say that they probably prefer him over either of those two guys.
Right. So Arthur, if you could do anything in the world that you wanted to do, what would you do?
I'm actually doing it. I know it sounds corny, but this is one of the things that's motivated me my whole life is technology. And I don't know if I could ever find a company that's more kind of fun to work with a lot of very intelligent people, and a great customer base. You know, dealing with the people that we deal with on a day-to-day basis, both internally and externally, you know, coupled with having the family back home and, you know, going home at night to see my kids and just everything, you know, I love my life right now, and I don't think there's anything I'd want to do differently.
That's excellent.
It's corny, but it's kind of the truth right now.
That's the way it should be. It's great. Well, Arthur, thanks for joining me today. It's been great.
Oh, and it's been my pleasure. Thanks, Erica.
You're welcome.
Thanks for joining us for another episode of the .NET Show.
And stay tuned for the next episode where we'll show you how to build your first .NET application.
And until then, we'll see you on the web.